Hello everyone, welcome back to my YouTube channel. I am Purnima NM from Sri Venkateshwara College of Engineering, Bengaluru. Now, in this video, we are going to discuss about the animation in physics. Animation is a method of photographing successive drawings, models, or even puppets to create an illusion of movement in a sequence. Animation is the process of displaying still images in a rapid sequence to create the illusion of movement. Types of physics animations: particle animations, wave animations, mechanical animations. Particle animations are these depict the motion and interactions of individual particles such as atoms or subatomic particles. Wave animations, these illustrate the behavior of waves including propagation, interference and reflection. Mechanical animations are they show the motion of objects and the principles of mechanics such as Newton's law of motion. Next, the taxonomy of physics animation methods. There are mainly two taxonomies, kinematics and dynamics. Kinematics is the study of motion without consideration of mass or forces. Dynamics is the study of motion taking mass and forces into consideration. Kinematics and dynamics come into two subgroups, inverse and forward. Inverse is the study of motion knowing starting and ending points. Forward is the study of motion solely given the starting point. Next, we are going to know about the frames per second, size and scale. Frames. In animation, frames are individual images that are combined in sequence to create an illusion of motion. The more frames there are per second, the smoother the animation looks. Frames per second. The speed of animation is measured in frames per second. A higher frame rate generally results in smoother and more realistic animations but requires more computing power. Size and scale. When designing the characters, you can run into situations having to do with size, scale, such as human or animal based characters that are much larger than we see in our everyday experience. Example, superheroes, Greek gods, monsters, etc. Human or animal based characters that are much smaller than we are customized to, such as fairies and elves. Characters that need to be noticeably larger, smaller, older, heavier, lighter or more energetic than other characters. Characters that are child versions of older characters. An example would be an animation featuring a mother cat and her kittens. If the kittens are created and animated with the same proportion and timing as the mother cat, they won't look like kittens. They'll just look like very small adult cats. Proportion and scale. Creating a larger or smaller character is not just a matter of scaling everything about the character uniformly. To understand this, let's look at a simple cube. When you scale a cube, its volume changes much more dramatically than its surface area. Let us say each edge of a cube is 1 unit length. The area of one side of the cube is 1 square unit and the volume of the cube is 1 cubed unit. If you double the size of the cube along with dimension, its height increases by 2 times, the surface area increases by 4 times and its volume increases by 8 times. Well, the area increases by squares as you scale the object, the volume changes by cubes. Next, the benefits of animation in physics. Animation allows for the visualization of dynamic processes that are difficult to observe in real life. It helps in conveying information more effectively and engagingly, making learning physics more enjoyable. Animations can simplify complex theories and make them accessible to a wider audience. Now, let us know about the timing. The timing is the choice of when something should be done, the regulation of occurrence and pace to achieve a desired effect. Animators have the ability to move forward and backward in time to place objects when and where they ought to be. The first is linear motion timing. The timing is the choice of when something should be done, the regulation of occurrence and pace to achieve a desired effect. Animators only have the ability to do it, which they can make the forward and backward in time of objects, when and where they ought to be placed also. Second is the uniform motion timing. When uniform motion occurs, the net force on the object is zero. Net force is the total of all the forces added up. There might be several forces acting on the object, but when the both magnitude and direction of forces are added up, they add up to be zero. Uniform motion is the easiest to animate because the distance the object travels between frames is always the same. Uniform motion is a type of linear motion with constant speed and no acceleration or deceleration. The object moves the same distance between consecutive frames. The longer the distance between frames, the higher the speed is. Slow in and slow out. When motion is accelerating or decelerating, we refer to this type of motion as a slow in or slow out. This type of motion is sometimes called ease in or ease out. Slow in. The object is slowing down, often in preparation for stopping. Slow out. The object is speeding up, often for a still position. Now the final part, conclusion. By incorporating physics principles, animators can bring lifelike movements and behaviors to the characters and objects, making the animated world more believable and engaging for the audience. Whether in films, video games, or simulations, physics plays a fundamental role in creating captivating and immersive animations. Thank you.